everyone. Here is a question on circular functions and trigonometry. In triangle ABC, side AB equals to 6 centimeters and side BC equals to 8 centimeters and angle B equals to 0.93 radians. The angular measure is in radian. We are asked to find the length of AC and also the size of angle C. Okay, now the question is a very simple question, but there's one thing that we need to take into consideration as far as the question is concerned, and that is because we are given the angular measure in radians. Okay, now let's see how this can be analyzed and how we can solve the problem. All right, so the first thing we need to do is to write down the given values. Okay, so first thing first, okay, let's write down what we are given. Now we are given triangle ABC, all right, with side AB equals to 6 centimeters, okay, BC equals to 8 centimeters, BC equals to 8 centimeters, and angle B equals to 0.93 rad. That's radian. All right, so to be able to analyze and solve this problem, so we need to first draw a triangle. So we have B, that's ABC. We have triangle ABC, okay? We're giving side AB, and which is the side opposite C, capital letter C. So we can designate this side with lowercase letter what? C. And that is lowercase letter C represents side, length of side AB, and that equals to 6 centimeters. Okay, then BC is lowercase letter what? A, because BC is the side opposite A, and that's what? 8 centimeters. Now the angular measure at B is 0.93 rad. That's radians. Okay, now we are asked to find the length of AC. AC is the side opposite angle 0.93 rad, and that will be represented with lowercase letter what? B. Now looking at the informations we have according to the question, okay, then we can proceed to use what we call the cosine rule. All right, so we're going to use the cosine rule, okay, to find the what? That's A now. So to find the what? The length. To find the length of AC. And we know that AC is represented, we have AC represented with what? Letter B. All right, so to use cosine rule in this case, all right, so we're going to use the formula B squared equals to A squared plus C squared minus 2AC then cos B. That's the formula to use, okay? All right, so to be able to calculate the value of B, so we can say B squared equals to A is what? 8. That will be 8 squared plus 6 squared minus 2 times 8 multiplied by 6, then cos 0.93. Now this will be 64, this is 36, and this is 8 times 6, 48. 48 times 2, that will be 96. So we have 96 cos 0.93. Okay, so 64 plus 36, that will be 100. Then we have 100 minus 96 multiplied by, cos 0.93 in radians is 0.5959. And that can be approximated to be 0.6. Okay, so let's get the value of 96 times 0.6, and that will be 57.6. So this will be 100 minus 57.6, so that B squared will be equals to, what is 100 minus 57.6? That will be 42.4. So we have this to be 42.4. Then the value of B will be, when we take the square root of, the value we get when we take the square root of 42.4. So the square root of 42.4 The square root of 42.4 is 6.5. So this will be equals to 6.5 centimeters. So B equals to 6.5 centimeters. That's the value of B. All right, the second question. The second question is for us to find the size of angle C. Now, to calculate the size of angle C, okay, now that we now know we now have the value for side AC. So to be able to calculate the size of angle C, then we're still going to use what? The cosine rule. All right. So again, use the cosine rule. Use the cosine rule to find the size of C. And because we want to find the size of angle C, that means we're going to use the formula cos C equals to A squared plus B squared minus C squared over 2AB. And we know the value of A to be 8 centimeters, the value of B to be 6.5 centimeters, and that of C to be 6 centimeters. So we then plug in the values. So we have A to be 8, and that will be 8 squared plus 6.5 squared minus 6 squared over 2 multiplied by 8 multiplied by 6.5. This will be 64. Okay, let's get the value for 6.5 squared. That will be 42.25. So this is 42.25 minus 36. Then let's multiply 16, because 2 times 8 is 16. Multiply by 6.5. Multiply by 6.5. That will be 104. So this will be 104. Then let's get the value for, what is the value for 64 plus 42.25 minus 36. Okay, that will be 70.25. So we have 70.25 divided by 104. All right, so what is 70.25 divided by 104? Now that will be 0. So we have cos C equals to 0.6754. So the size of angle C, okay, will be equals to whatever we get when we take the inverse cos of 0.6754 or 6755. 0.6755. So the inverse cos of 0.6755, that will be 47.5. So we have, that will be 47.5 degrees. Now, this is the angle in degrees, okay? And let's not forget that the size of angle B is in radian. So it is important for us to convert this angle, the size of angle C, from degrees to radian. So we then use the radian degree conversion formula. All right. So to convert the size of angle C from degrees to radians, so we then write, so size of angle C in radian, that will be 47.5 multiplied by pi over 180 degrees. So let's be very careful in this case. All right. Now, of course, we know that 1 pi radian equals to 180 degrees. And let's not conclude that this will be 180 divided by 180. No. So we are going to write the value of pi, which is 3.142. Okay. Then use it to multiply 47.5. And then when we multiply that, then we divide by 180. All right, so this will give us, this will be 47.5 pi over 180 degrees. So what is 47.5 multiplied by the value of pi? That will be 149. Okay, so let me write it here. Size of angle C. Continuation, okay? So we have 47.5 pi over 180. That will be 149.245 divided by 180. So when we divide this by 180, Okay, that will be, so size of angle C will be equals to 0.829, and that will be approximately 0.83 rad. So which means size of angle C in radians is angle C equals to 0.83 rad, and that is the value for the size of angle C in radians. The noblest pleasure is the joy of understanding. Bye bye.